topic of this video is the KSP. KSP is the solubility product constant. All right. And with this idea or with this phenomena, we're going to go to this solubility chart. All right. Solubility chart's this chart that tells you what's soluble in water and what's not soluble in water. Let's look at silver chloride, A. It's insoluble. Or something like barium carbonate, partially soluble, or barium sulfate. It's A, not soluble in water, all right? Well, the fact of the matter is there with solubility has a grayness to it. In that insoluble things are soluble, all right? I'm going to put this in quotes. So, one insoluble salt is a silver chloride, all right? But if I had silver chloride in a solution, it would saturate the solution, or I should say, if I had silver chloride in water, it would saturate it really quickly because it's only really slightly soluble. All right. And this is where my KSP, my solubility product constant. Now, KSP talks about the solid becoming dissociated. I was stuck on the AQ. All right. And this is just like any other equilibrium. It the expression of my solubility product or equilibrium solubility constant is going to have this, and it's not going to have the solid, so it's going to be dependent on those two things. All right. So that's what the KSP is in terms of its equilibrium constant. It is not on here. It's not one of the ones given, even though you can derive it in that it's always equilibrium is always products over all of these are all products over reactants, but you'll see KSP is not one of the ones there. I want to add something to this picture. They saturate really or with very little. All right. Okay, now here's a table in TRO, page 818. You'll notice we're mainly looking forward or looking at these exponents. These are all negative numbers. It means they're very slightly soluble. Very little will dissolve, but some will, and I will show you that in a second. Okay, let's go with calcium fluoride. Its KSP, or its solubility product constant, is 1.46 times 10 to the 10th. So first, you're going to need an equation. Plus 2F negative, and my KSP is 1.46 times 10 to the negative 10th. Well, that means that my my KSP is also equals to the concentration of calcium all right. Oh, that should be squared. So 1.46 times 10 to the negative 10th equals the concentration of calcium to F negative 2. All right. Now to solve this, I'd want an ice table. All right. So what's my concentration? Um, if oh shoot, where does my mouse go? So at all right. So if at equilibrium, what's my concentration of these things going to be equal to? I'm going to need my ice table. All right. So CaF2, Ca plus 2, 2F negative. The concentration of the solid doesn't really matter. I'm going to start with 0 of this, right? Some amount x is going to dissolve. This would be 2x, all right? And that is all going to go back into my equilibrium expression. So 1.46 times 10 to the negative 10 equals x times 2x squared. So this is going to be equal to 4x cubed. So then I'm going to need to, so the whole thing is going to be the cube root of 1.46 times 10 to the negative 10th divided by 4 equals x. All right? So now I plug that in. So I get 3.31 times 10 to the negative 4th equals x. All right, and that's the concentration. Remember, you got to plug that back into your rice table or your ice table. That's the concentration of copper, and I would double it for the concentration of fluorine. So the concentration of fluorine is 6.62 times 10 to the negative 4th. All right, and the units on these are moles or moles per liter. All right, and that's KSP, and that's how you would what it is and how you would solve for it at equilibrium.